So today we've done translations, we've done reflections. Another way that we could transform things is that we're going to do rotations. Okay? So what is a rotation? Well, a rotation is a transformation that turns a figure around a given point called the center of rotation. And then that image has the same size and shape as the pre-image, but what do you notice that's missing? Not the same orientation. So write that in real quick. Not the same orientation. So if you're ever doing the PSAT and you notice that the orientation is the same, what type of transformation is that? It's a translation, right? And if you notice, and if they say find the translation, and all the graphs but one have a different orientation, the one that doesn't have it, okay? So there's little clues they give you. Anyways, they want us to fold paper, blah, blah, blah. We're not folding paper. You can't fold paper on the SAT. So we're going to try to figure this out the old school way. Folding the paper is fun, but it's like doing algebra with M&Ms, right? If I say, if I have 5 M&Ms, how many more M&Ms do I need to have 8? And you guys will add the extra 3 M&Ms, and then you eat the M&Ms. That's fun. But when I say x plus 5 equals 8, that's a different thing. I prefer to make you guys think a little bit, which is harder at first, but it really helps cement the stuff in your head. So anyways, we're going to do it a little bit harder up front. So we're asked to rotate this image about the origin. What is the origin? What point is that on the graph? Yeah, it's 0, 0. When x equals 0, y equals 0. So our point of rotation, our center of rotation is right there, 0, 0. And it wants us to rotate it 90 degrees clockwise. Counterclockwise. Thank you. Sorry. So remember, now if you don't know this, what clockwise and counterclockwise is. This is clockwise. Whoops, wrong device. So this is the way a clock spins. So that's clockwise. And then I'll write this one the other way. So counterclockwise goes the opposite way that a clock spins. So if you're ever wondering, look at my clock. If you see the second hand, it's spinning one way. That's clockwise. The other way is counterclockwise. So this way is counter.
Wait, what?
Yep. Knew that was coming.
That's left counter. I'm still left. Clock is right.
Well, you could think of it, but that's if you start at the top. Some people start at the bottom.
Either way, you're still going one way.
No, if you start at the bottom, you're going to the left. So always think of it the way the clock spins, okay? So they put an arrow on there for us to kind of help us. So we're going to rotate 90 degrees this way. Well, guess what? A, and this is a little bit hard, but A prime is just going to be right here because that's where we're spinning. But now B is going to rotate 90 degrees. So you kind of can draw a circle and you go 90 degrees. So if this is 0 degrees, this is 90 degrees, this is 180 degrees, and this is 270 degrees. And we start with 0 degrees and we rotate this way. So this would be B prime. I'm going to draw a little arrow there. That's B prime. This is A prime. And then C rotates. And so C is, and this is the tricky part, C is 1, 2, 3, 4 units away from B prime. So you're just going to go 1, 2, 3, 4. And so that's C prime. So now we got to connect the dots. So I'm going to go from here to here. then from here to here. Oh, I hate that thing. It's funny, I gotta lift my pen straight up. Then from here to here. And how many of you guys got an image like that? Did you try to do it on your own?
I started trying.
Okay, cool. So let's think about the question. So now that we've sketched the image, describe the motion modeled by the rotation. What words would you use to describe that? Rotate what? Oh, wrong tool there. 90 degrees. Well, we can't say left or right. We have to use the terminology they gave us. Counterclockwise, good. Counterclockwise. That's a big word. Counterclockwise about the origin. And then it says, check the motion you described in D is the same motion that maps A to A prime. And so what they're saying is check the motion is A doesn't really rotate, but B rotates 90 degrees. So if I measure from here to here, it's 90 degrees. If I measure from here to here, it's 90 degrees. Okay? Does that make sense? Now, it says communicate mathematical ideas. How are the size and the orientation of the triangle affected by the rotation? Same size. Different orientation. That's a Z there. Same size. Different. Orientation. Oh, almost misspelled the word orientation. See, you guys want to catch me making a mistake. It won't happen. Yeah, it will. So now it says, take ABC and rotate it 90 degrees clockwise about the origin. Actually, let me change the color of that. Now we're going to go clockwise. So let's do, what color should we do? Let's do red. So let's rotate ABC 90 degrees clockwise. And we'll call it A prime double prime. Well, guess what? A prime and A double prime are all the same because that's our center of rotation. Now, to go clockwise, that means I'm going to rotate this way. So right here is B prime, double prime. I'm going to move my A prime. Can I erase this? Yeah, let me move that. Let me move that so it's kind of out of the way. How can I do that? Let's do it like A prime. And then C prime rotates around 90 degrees, which is 4 units this way. 1, 2, 3, 4. That's the tough part. Obviously, Mr. Adams has had a lot of practice with this, but that's the tough part. Oh, that's the wrong color. Oh, I hate that thing. And that last one is C double prime, right? And that's basically it. Let me zoom out so you guys can see it all. Are there any questions on this? Now, it isn't always going to rotate on one of the vertices, so that's another thing you got to think about. Okay? But notice that this long line is rotated 90 degrees, and this long line is rotated 90 degrees. This short line is rotated 90 degrees. This one, one's going clockwise, one's going counterclockwise. Okay, that's it. I'll leave that up. It's almost time to go.